Biomechanical Principles of Osteosynthesis. Part 3. The Tension Band. For this concept, let's use a transverse patella fracture as example. The patella isn't a straight rod. It's a curved bone that acts like a pulley for the extensor mechanism. The quadriceps tendon pulls the superior pole, and the patella tendon pulls the inferior pole, while the patella is also pressed against the femur. Because of this geometry, the pull is eccentric relative to the fracture plane, meaning the line of action is off-center, so it creates a bending moment, not just pure straight line tension. That bending makes the fracture behave like a book. The anterior surface is the side that tends to gap open under load, and the posterior articular side stays closer. Without a tension band, the anterior side is free to open. Contact at the fracture site is lost. However, with a tension band implant on the anterior side works like a strap that blocks opening. When the extensor mechanism creates a bending moment, the anterior cortex tries to gap. The wire is put into tension and holds the front closed. Because the front can't open, the same bending load is carried as a pull in front and a squeeze in back, generating compression across the articular fracture surface. Using the book example, when you try to open the book, the strap tightens and prevents the front from opening. Because the front can't gap, the load doesn't disappear, it's carried differently. The opening on the tension side becomes tension in the strap, and that tension pairs with compression on the opposite side, squeezing the fracture surfaces together. Next subject is compression. Compression in osteosynthesis means clamping the fracture surfaces firmly together, so the two fragments act like one continuous bone. The goal is absolute stability. Biomechanically, compression works because the squeeze creates a strong pressing force between the bone surfaces. That force increases friction at the interface, so it prevents shear and reduces gapping when the limb is loaded. In this low-motion environment, the bone can heal directly with no visible callus. This is why compression is classically used for simple fracture patterns, where the surfaces can be accurately reduced and pressed into contact, and in situations where maintaining precise alignment is essential, like joints. Some implants that can generate compression are the lag screw and the compression plate.